Welcome to MATGAS. We feel happy and honored to open our doors to you today. The name MATGAS stands for Materials and Gases. The building is located in Barcelona, Spain, in the campus of the Autonomous University of Barcelona. We belong to the Global Technology Centers, doing research and development for the different businesses of the company. MATGAS is also a joint venture, a strategic alliance offer products with the National Research Council of Spain, CSIC, and the Autonomous University of Barcelona, UAB, being Air Products the main honor. Today you will visit our facilities, the 6 laboratories in which we do research, development and demonstration in energy, sustainability and environment, in specific areas of interest to our products and also to the other 2 partners, CSIC and UAB. As you will see in MATGAS, we do integrated projects using this facility and also collaborating with the highly reputed institutions surrounding us, firmly based in open innovation. You will see our labs and meet our people. We hope you enjoy it.
MATGAS was born 10 years ago as a strategic alliance between Carburos Metálicos, part of the Air Products Group, the National Research Council of Spain, and the Autonomous University of Barcelona. These 3 institutions joined forces with the goal of becoming a centre of excellence in materials, science and gas applications, combining the synergies between industry, academia and public research for the benefit of its founders and society. A centre with its own staff and its own projects, doing research in a different way. In 1997, the 3 partners signed the first collaboration letter. Then in 2001, the legal entity was formed, and the project took shape with the construction of the MATGAS building, which opened in 2005. A new strategic plan was implemented in 2008, marking the continuous growth of the research centre and helping to shape MATGAS into what it has become today.
With the formation of MATGAS 10 years ago, we brought together a unique combination of business, research and development from universities and public research institutions. Working towards the same objectives, it's a very powerful force for change, furthering research and development in a unique way and contributing to several of society's biggest environmental and energy challenges. And for Air Products, our involvement enhances our own approach to research and development in many other areas of our business, especially with our focus on sustainability. I am very proud of what everyone associated with MATGAS has achieved over this last decade. Congratulations.
The vision of MATGAS is to become a world-leading centre of excellence that integrates research, technology development and demonstration in energy, sustainability and environment, focused on greener energy solutions, including CO2 capture and application, waste treatment and alternative energies, by combining modelling and experimental approaches. MATGAS employs 35 people, including 12 PhD, coordinators of scientific areas, postdoctoral researchers, laboratory technicians and students. 13 of them are Air Product employees. The total budget for projects in 2010 exceeded €15 million. Research and development at MATGAS is implemented through 7 research lines, 5 vertical and 2 transversal, developed in 6 labs, which we are going to visit in depth. The Gas Reactivity Laboratory is designed for the study of the reactivity and absorption of a variety of gases into liquids or solid materials. This can be done by volumetric as well as gravimetric techniques and over a wide range of pressures and temperatures.
In this lab, there are special equipment, 2 tailor-made magnetic suspension microbalances, as well as an equipment for the preparation of new materials for absorption of gases by sputtering UHV. This lab also offers state-of-the-art equipment for materials characterization. With this unique equipment, we are on one side developing and testing new technologies, such as materials for CO2 capture, and on the other, improving the performance of our existing processes, for example, HYCO.
Here is an example of how the microbalance provides data on materials for CO2 capture under real operating conditions and in a cyclic manner.
The Supercritical Fluids Laboratory carries out the research and development of new applications of supercritical fluids, in particular CO2.
This laboratory was initiated more than 15 years ago in collaboration with the SIG. The laboratory is equipped with several high-pressure reactors with different configurations and sizes, from 10 milliliters to 16 liters. It also includes a pilot plant for scale-up applications. We have developed different projects, including extraction and concentration of natural products for the food industry, polymer impregnation, corrosion of effects of gas impurities in materials, CO2 transportation and sequestration, and synthesis of new materials.
I'm using the supercritical CO2 technology to recover unused oil from a restaurant. The same process can be used to extract oil for making biofuel for different biomass products.
The Nanotechnology Laboratory is a last-generation lab equipped with the needed techniques for the characterization and manipulation of materials at nanoscale. This laboratory allows a comprehensive study of the properties of nanostructured materials, including size, mechanical, thermal, optical, structural, and electrical properties.
The Nanotechnology and Materials for Energy Lab provides different equipment for the assessment and characterization of materials at the micro and nanoscale, for applications in different areas like electronics, energy, PMD, and also other. Among the different equipment, we have a high-resolution Raman scattering, an nanoindenture system, and an atomic force microscope, which also has electrochemical capabilities. Some of the projects we have been working on are related to thin films for photovoltaics, corrosion of surfaces, and also conversion of CO2 to added value products.
We use the AFM to monitor corrosion process in situ. This is an example of one of our wafer cleaning chemistries for the electronics industry. Here, we test the better performance of a new product.
MATGAS also has a research line dedicated to food preservation, where we look for integrated solutions for food preservation. This is done in the food laboratory. The facility is equipped with the last generation equipment related to food packaging and different gas mixtures.
The food laboratory was created 10 years ago as a strategic alliance between Air Products and IRTA in Barcelona. The main objective of this unit is to provide integrated solutions that can extend food shelf life both sensorial and microbiological level, offering quality end products for the food industry. We also promote the innovation and technology transfer related with food preservation with our customers. We develop specific projects demanded by them, for instance, checking the appropriate gas mixtures for each kind of food, fish, fresh fruits, cakes, among others, to achieve the adequate shelf life. And also, we develop R&D projects of interest to Air Products in accordance to market trends and opportunities for the company.
I'm packaging a fresh cut salad in a vertical form-filled seal packaging machine that works removing the air inside the package by introducing the right gas mixture with nitrogen, carbon dioxide, and oxygen. With this system, we avoid the effect of vacuum in this kind of product, and we can prolong the shelf life of the salad.
The Computational Modeling Laboratory is a permanent calculation infrastructure to provide support to MATGAS projects from a modeling perspective. Simulations performed in this lab help to obtain a deeper understanding of properties and processes at nanoscale and/or for different applications.
MATGAS maximizes the synergies resulting from a combination of simulation and experimentation. Simulations performed at the computational lab aid the understanding of the properties and processes which take place at the atomic level, as well as the design and optimization of processes at the industrial scale. For this purpose, the computational modeling lab is equipped with state-of-the-art supercomputing facilities and the adequate software. Examples of recent projects developed here include hydrogen storage in carbon nanostructures, the position of copper layers as electrical contacts in microelectronics, the optimization of nanoparticle dispersions, the design and understanding of the behavior of materials for CO2 capture, the behavior of selected ionic liquids for different applications, and computational fluid simulations of the gasification of biomass waste.
One of the projects we're working on is the design and optimization of materials for different applications. As an example, you see here an inorganic hybrid material functionalized with amines. The green molecules here represent the CO2 interacting with the functionalized surface.
The Green Energy Laboratory offers facilities related to the study of new sustainable energies. This includes a hydrogen fuel cell test bench, several potentiostats for electrochemical characterization, and different tools for the development of water treatment processes and bioenergy.
This is a very versatile laboratory in which have developed different projects with the common baseline of sustainability, ranging from green hydrogen to wastewater treatment and new sources of energy. I'm working in tested membrane for hydrogen fuel cell at high temperature for combined heat and power application. This work is developed in the context of European funding project LOLIPEM.
We also work in several applications for water treatment. The ALIA Advanced Oxidation Reactor, developed by Air Products, combines ozone and hydrogen peroxide to produce hydroxyl radicals, one of the strongest oxidants. The treatment process is applied to taste and other compounds, microcontaminants such as endocrine disruptors and recalcitrant compounds, making it ideal for water reuse, disinfection, and even drinking water applications. With this reactor, we can also do trials for specific customers coordinated with the marketing and commercial teams.
As part of our commitment to sustainable development, at MATGAS we apply the tools of life cycle assessment to the new processes and products we develop, from CO2 capture to different technologies for the treatment of water and food preservation. At MATGAS we work to improve the net environmental gain on processes and products. MATGAS is part of the Catalan and Spanish LCA network. MATGAS collaborates in emblematic projects carried out with company consortia as well as public and private research centres. Since 2008, MATGAS has coordinated the technical work of the Senate-SOST CO2 project with the global objective of developing technologies for the utilisation of CO2 complementary to CO2 capture. The consortium involves 14 companies and 29 research centres with a budget of €26.4 million, and it is partially financed by the Spanish government through CDTI. MATGAS also participates in the Senate Biosus project, led by Abengoa Bioenergy and also supported by CDTI. The project is focused on the development of sustainable biorefineries, specifically on the conversion of waste from the paper industry into useful resources. In its search for alternative energy sources, MATGAS is a partner of the LOLIPEM European project, which is focused on developing high-temperature membranes for hydrogen fuel cells that can be used to produce both heat and electricity. Our partners' support is our best guarantee. In the last 3 years, MATGAS has doubled the budget assigned to research projects to more than €2.5 million in 2010, participating in projects amounting to a total budget of over €15 million across the various research lines. The dissemination of research and technology transfer activities that take place at MATGAS are key to the visibility of the centre and its research, and thus its ability to find new synergies with other companies, public centres and/or research groups. Consistent with the participation in research and development, the number of scientific papers published in international journals has increased spectacularly, with a total of nearly 60 articles in 5 years. Moreover, in the last 3 years, 6 doctoral theses have been defended, and many others are currently ongoing. Thanks for visiting MATGAS.